Intercepts can tell us really important information related to applications. For instance, let's take an example of a compass accidentally thrown up and out of a hot air balloon. I have a picture below of a little stick figure in a hot air balloon. The function y equals negative 16x squared plus 20x plus 300 can be used to describe the height y in feet of the compass x seconds after it's thrown. Now, as you can see, it gets thrown and it heads down toward the ground in our picture. Let's talk about what the intercepts represent in this scenario and how we would find them. Well, first off, we've been graphing equations, so a really nice thing to do first would be to graph this in decimals, and I actually have the graph already printed for you. One thing to note is that I did change the scale using the graphing utility, the graphing window utility, the little wrench. So I have an x-axis going from -2 to 6 and a y-axis going from about -10 to 300. Or a little over 300. The x and y intercepts can be seen on this graph. Technically, you don't only see one of the x-intercepts. You could imagine this graph continuing down. The reason I didn't graph this part of it is that if we think about what x means here, x is in seconds since the compass was thrown, and seconds is something that happens in a positive amount of time. Remember, we think about 0 seconds as being when it's thrown, and then we think about what happens forward in time, not backward. So we don't really consider what happens before 0 as part of the application. So in the application here, the x-intercept that matters is the one that is for positive time. And we can see that that location is 5, 0. And then our y-intercept here we can see started at 300. Now what do those mean, 0, 300, and 5, 0? Well, remember, x is in seconds and y is in feet. So this y-intercept is saying that 0 seconds after the compass is thrown, so basically when it's thrown, the height of the compass is 300 feet. So when the compass is thrown, it was at a height of 300 feet. The x-intercept, again, the first value is seconds, the second value is feet. This is saying that 5 seconds after it's thrown, the compass is at 0 feet. 0 feet would be on the ground. So the compass is on the ground after 5 seconds, or it hits the ground after 5 seconds. To find intercepts algebraically, we need to think about the coordinates of intercepts and how they always have 0 as one of the two values. When you're looking for a y-intercept, you're on the y-axis, so your x value is 0. So to find a y-intercept, we set x equal to 0. So I plug 0 in here. We have something really nice that happens, which is that any term with an x in it basically goes to 0 because 0 times anything is just 0. So we very quickly get our y-intercept with really very little effort, 0, 300. Unfortunately, it's not so easy to find the x-intercept. To find the x-intercept, we set y equal to 0, and instead of having nice calculations, we get a fairly complicated equation. An equation 0 equals negative 16x squared plus 20x plus 300. Because of the x squared term, this is what we call a quadratic equation. To solve a quadratic equation, we have to go to some elaborate measures. You may have in a previous class learned how to use the quadratic formula. This term we're going to investigate how to solve these guys with what's called factoring. We're going to use this technique of factoring in several ways this term. One way will be to solve equations like we saw on the last page, quadratic equations as well as more complicated equations. But we'll also be using factoring to help us simplify complicated expressions. For instance, like this fraction, x squared minus 7x plus 10 all over x squared minus 4. This is called a rational expression, and we'll be using them quite a bit later on in the class. So we're going to spend the next 2 weeks on factoring, but it will be used throughout the term, and it's going to be important later classes like college algebra and calculus.